Welcome to the short video introduction to stereophotogrammetry and 3D printing, presented by Pennsylvania State University students Jason Isaacs, Nicholas Pace, and Joe Stanislawczyk of the Information Sciences and Technology course IST 110. Imagine yourself in a future where any object you see can be easily duplicated without having prior knowledge of engineering or manufacturing techniques. Envisioned by Gene Roddenberry's Star Trek science fiction universe, today's technologies are quickly approaching replicator-like devices in reality. While science fiction makes such devices appear simple, in practice, such a device will be very complex. To begin with, in order to materialize an object out of thin air, a blueprint for that object is required. There are many techniques to reverse engineer an existing object, but one of the more recent advancements is in the area of stereophotogrammetry. Stereophotogrammetry is a technique that utilizes photographs taken from multiple angles of an object in order to triangulate its edges and points. The result is a 3D computer model created by simply observing an object without direct contact. With today's computing power, we can create fairly accurate models under the right conditions. As advanced as this technology has become, the technique has been known for quite some time. After the introduction of commercial photography in 1839, a military engineer in France named Aimé Laussedat pioneered the foundations of photogrammetry in 1851. However, it was those who followed in Laussedat's footsteps who refined and expanded his techniques to create what we know today as stereophotogrammetry. German architect Albrecht Meydenbauer in 1885 and Dr. Karl Polfrick in 1901 provided invaluable contributions to the discipline. It is unlikely that any of these men could foresee such a strange device such as the Star Trek replicator, or that their work would one day be leveraged by such a device. Recent advancements in 3D printing technologies have made it possible for consumers to affordably manufacture real-world representations of 3D models either directly in their home or via online printing services. While the automation necessary for this kind of manufacturing is quite sophisticated, the underlying principles are rather simple. In the early 1980s, Charles Hull was one of the first pioneers of additive manufacturing techniques. His process utilized ultraviolet light and photosensitive curing materials that would harden when exposed. By creating cross-sections of a 3D model and manufacturing it one layer at a time, using his technique, it was possible to manufacture physical models with very high precision, strength, and other physical characteristics. Combined with computer automation, this technique can yield very precise physical models. Over time, this process has resulted in other techniques that create models with different qualities. The most affordable has been fused deposition modeling, that creates a model layer by layer by extruding a filament of molten plastic. FDM creates a cross-sectional contour and then rasterizes the fill of the layer to create a solid or internal mesh within the part for reduced weight and cost. This process is the simplest and most affordable, as it only requires computer motorized automation, heating element, and thermoplastic filament. Together, 3D printing and stereophotogrammetry technologies are a powerful combination. The real-world applications are virtually limitless, spanning from medical, engineering, and consumer items. The diversity of materials make 3D printing a very robust manufacturing technique, from printing replacement organs to a chocolate confection. We're only starting to realize the implications of such powerful technologies. There are many rising concerns over intellectual property theft and manufacturing of regulated or banned items such as weapons. As such technologies become more advanced and more accessible, it will require our society to rethink policies regarding intellectual property rights and regulation. The truth of the matter is that we cannot anticipate what will become of these technologies or how they will challenge the fabric of society. It is truly a brave new world.